There are two basic types of four-wheel drive systems available on Toyota vehicles: part-time four-wheel drive and full-time four-wheel drive. Part-time four-wheel drive vehicles are designed to be operated in four-wheel drive mode in off-road or slippery conditions only, therefore the name part-time four-wheel drive. In contrast, most full-time four-wheel drive vehicles can be operated in four-wheel drive mode on all driving surfaces, therefore the name full-time four-wheel drive. Toyota's part-time four-wheel drive systems are available on the Tundra and Tacoma trucks and the FJ Cruiser with automatic transmission. Full-time four-wheel drive systems are available on the Land Cruiser, FJ Cruiser with manual transmission, 4Runner, Sequoia, Sienna, Highlander, RAV4, Matrix, and Venza. Some of these Toyota models use variants of the full-time four-wheel drive system, like the Sequoia and 4Runner V6, which use a multi-mode system. The current Sienna and Highlander use an all-wheel drive system, and the Matrix all-wheel drive, RAV4, Venza, and Highlander hybrid use on-demand systems. We will explore all of Toyota's four-wheel drive systems in more detail in the next sections. In part-time four-wheel drive systems, the vehicle is mostly operated in two-wheel drive mode, directing the power to the rear wheels. When the driver manually selects four-wheel drive mode, the power is directed to all four wheels. Click the Play Animation button to see how a part-time four-wheel drive system works. Select a name label on the illustration to learn more about the four-wheel drive key. Full-time four-wheel drive systems and its variants are available on the Toyota models shown here. Select a full-time four-wheel drive system to learn how that system works. Each full-time four-wheel drive system is numbered to suggest the order in which you should make your selections. Full-time four-wheel drive systems direct power to all four wheels full-time. Full-time four-wheel drive vehicles may be operated in four-wheel drive mode on dry pavement as well as on slippery surfaces. This is an important difference between full-time four-wheel drive and part-time four-wheel drive vehicles. The reason a full-time four-wheel drive vehicle can be driven on both dry pavement and slippery surfaces is due to the use of a center differential, a feature part-time four-wheel drive vehicles lack. Select a label on the illustration to learn how that component or feature functions. The 4Runner V6 and Sequoia models use a multi-mode four-wheel drive system. This system operates in full-time four-wheel drive mode, but also allows the user to select two-wheel drive where the additional traction of four-wheel drive isn't needed. The two-wheel drive mode provides better gas mileage and reduced component wear. Select a label on the illustration to learn more. The Sienna and Highlander's full-time all-wheel drive system sends variable power to both axles. It incorporates the front differential, center differential, and transfer case into one compact unit. The rear differential is located at the rear axle. The all-wheel drive system relies on a specialized electronic control unit, or ECU, to control wheel spin by applying the brake to that wheel and therefore direct power to the other wheels with traction. Select a label on the illustration. Select the electromagnetic coupler or electric motor generator to learn how these on-demand four-wheel drive systems work. Electromagnetic coupler. During normal driving, the electronic on-demand four-wheel drive system defaults to front-wheel drive only mode to improve fuel economy. An electronic on-demand four-wheel drive system with an electromagnetic coupler is featured on the Matrix all-wheel drive, RAV4, and Venza. This type of differential automatically provides torque as road and driving conditions change. It uses an electric solenoid and circular magnets to vary the amount of torque sent to the rear wheels. This electronic on-demand four-wheel drive system is best suited to enhance traction on loose or slippery surfaces and is not designed for heavy-duty off-road use. During acceleration, tight cornering, or when one or more wheels are spinning, the vehicle's four-wheel drive electronic control unit, or ECU, automatically increases the amperage sent to the electric solenoid, which in turn actuates a main clutch assembly containing a set of discs via a control clutch within the center differential. With the main clutch engaged, torque is transferred from the front housing of the coupler through the disc pack to the output shaft, and to the rear differential and wheels for added traction and stability. If the four-wheel drive ECU sends low amperage to the solenoid, a lesser amount of pressure is applied to the disc pack, resulting in a smaller amount of torque directed to the rear wheels. Higher amperage sent to the solenoid produces a larger actuating force on the main clutch discs, which results in a higher rate of torque being directed to the rear wheels. The amount of torque to the rear wheels is infinitely variable through the application of current, as directed by the four-wheel drive ECU, up to a maximum of 45% rear and 55% front torque distribution. The electronic on-demand four-wheel drive system has a four-wheel drive lock switch, allowing the driver to send maximum torque to the rear wheels. Power is then split almost equally between the front and rear wheels, with roughly 55% of available power sent to the front wheels and up to 45% of available power sent to the rear wheels. The four-wheel drive lock will automatically disengage above 25 miles an hour and during braking. Electric motor generator. The Highlander Hybrid uses a unique electronically controlled on-demand four-wheel drive system. This four-wheel drive system adds a separate rear electric motor generator that is integrated into the rear differential assembly. Because this rear differential receives its power from the battery, there is no need for a drive shaft or transfer case, as would be found in typical mechanical four-wheel drive systems. When driving conditions require additional traction at the rear wheels, the skid control ECU sends information to the hybrid system ECU, which activates the rear motor. The driver doesn't need to operate any four-wheel drive controls, since the system is activated and deactivated automatically. Under normal driving conditions, when there's no need for the added traction provided by the rear motor, the Highlander Hybrid operates solely in front-wheel drive mode. The rear differential motor will engage during startup, full acceleration, tight turning maneuvers, and when low traction or slipping is detected at the front wheels. The Highlander Hybrid on-demand system is best suited to enhance traction on loose or slippery surfaces and is not designed for heavy-duty off-road use.